Today, we're going to decode a concept that's in your morning coffee, your medicine cabinet, pretty much everywhere. It's totally fundamental to all of chemistry, and it's called concentration.
I mean, have you ever really thought about it? What makes one cup of coffee so much stronger than another? Or, on a more serious note, how do scientists get the dose exactly right in a medication?
Well, the answer to both of those things, and a whole lot more, all comes down to one crucial idea: concentration. You can think of it as the language chemists use to talk about the strength of a mixture, and today, we're going to learn how to speak it.
So here's our game plan. First, we'll cover the absolute basics. What even is concentration? Then we'll look at a method you already see every single day: percentages. After that, we're going to dive deep into the real chemist toolkit and meet something called the mole. We'll even check out some super specialized tools before we figure out how to pick the perfect one for any situation. Sound good? Let's jump in.
Okay, so let's start at square one. What are we actually talking about when we use the word concentration? At its core, it's actually pretty simple. Concentration is just a way to measure how much stuff, which we call the solute, is dissolved in some other substance, the solvent. So think about making Kool-Aid. The powder is the solute, the water is the solvent. The more powder you dump in, the higher the concentration and the stronger the flavor. Simple as that.
And listen, this isn't just some textbook definition. Getting the concentration right is the critical first step for almost any experiment that involves measuring stuff. It doesn't matter if you're in a university lab or a giant factory. If you mess up the concentration, everything else you do after that is basically useless.
All right, now let's move on to a way of measuring concentration that I guarantee you've seen a million times, whether you realized it or not.
We see percentages on labels all the time, right? But what's interesting is that the word percent can actually mean a few different things in chemistry. As you can see here, it can be a comparison of weight to weight, volume to volume, or even a mix of the two. It all just depends on what kind of stuff you're mixing together.
So percentages are awesome for everyday stuff, but, in the world of professional chemistry, you need way more precision. And that's where we open up the real chemist's toolbox. It all starts with a clever way of counting particles. See, atoms and molecules are just impossibly small. You can't count them one by one. So chemists came up with this brilliant idea: the mole. Just think of it like a chemist's dozen. You know how a dozen always means 12? Well, a mole always means the same very, very large number of particles. And this one idea is the key to everything else.
Okay, first up is molarity, with a capital M. This is the absolute workhorse of the chemistry lab. It's super straightforward. It's the number of moles of your stuff, your solute, divided by the total volume of the final solution, measured in liters.
Next, we've got molality, with a lowercase m. Now, I know it sounds almost identical to molarity, but there is one tiny difference that is a huge deal. Molality is the number of moles of solute per kilogram of the solvent you started with. So let's put them side by side, because this is so important. Molarity is based on the final volume of the whole solution. Molality is based on the mass of just the solvent. So what? Well, here's the kicker. Volume can actually change when things get hotter or colder. But mass never changes. So if your experiment involves changing temperatures, molality is your best friend because it stays rock solid and reliable.
Okay, so beyond those two big ones, chemists have a few other tools in their belt for very specific, very precise situations. Let's call them the specialist tools.
Just take a look at this number for a second: 1 million. Now, what if you had to find one single tiny thing hidden inside a million other things?
Well, that's exactly what parts per million, or ppm, is for. It's the unit you pull out when you're talking about incredibly tiny, trace amounts of something. We're talking about finding a single drop of ink in a whole bathtub of water.
And this is a perfect example of why it's so important. As AK2 Digital Education points out, this is used all the time in the drug industry. You have to be able to detect even the smallest possible impurity in a medicine, right? ppm is the tool that lets scientists do that and keep people safe.
And our final specialized tool is called Normality. Now, this one is a little different. It's kind of like molarity, but it's smarter. It actually takes into account how a substance is going to react in a chemical reaction. It's a very specific tool for a very specific type of calculation, something you'd use in a technique called a titration.
Okay, so we've looked at percentages, molarity, molality, ppm, and normality. That is a lot of options. So how on earth do you know which one to use?
Well, it really just comes down to picking the right tool for the job. It's that simple. If you're labeling a bottle of vinegar, percentage is perfect. For most day-to-day lab stuff, molarity is your go-to. But if that lab work involves temperature changes, you'll want the stability of molality. Hunting for tiny impurities? That is a job for ppm. And for those very specific reaction calculations, normality is your specialist.
Which of course brings us to the ultimate question. After looking at all of these, is there one method that's just better than all the others? And the answer is nope. There is no single best way. The best method is always the one that fits the job you're doing. Understanding concentration isn't about memorizing formulas, it's about knowing which tool to pull from the chemist's toolbox. And now, you know what's in the box.